Welcome. My name is Gary Wagner. I'm the General Manager of Ophir-Spiricon in Logan, Utah. You know us as a premier supplier for laser measurement equipment. Why measure a laser? Well, a laser is like an incandescent light bulb. The system is changing over time. Depending on the application, change is bad. An example would be LASIK eye surgery. If you want to have the same process from procedure to procedure, it needs to be calibrated. You'll find our equipment in such machinery, and before every operation, they calibrate it to make sure the laser is within proper operating conditions. Well, there are two major characteristics that you want to measure in a laser. One is power and energy, and the other is spatial distribution. Power and energy is this equipment that you see behind us here. The laser is shined on a sensor, and depending on what the wavelength of the continuous or pulsed energy is, a different sensor for each of those conditions. Each sensor is connected to a meter. The meter can be handheld or it can be focused USB through the PC. The other characteristic is beam profiling. You want to measure how the power is distributed inside the beam. If you want to cut, you want all the power to be right in the center, like the shape of a pencil. If you want to weld, if you had that power all in the center, you'd poke a hole right through the weld. So you want the power evenly distributed across the beam. Let's say this is my beam profile. Now, what we would do is we take this and we put it on the face of a camera, an imaging sensor. Like this sensor we have back here, laser going into the camera. The image from the camera is interpreted right here by the beam gauge software, our premier software for measuring profiling. Now, what we're featuring here at Photonics West 215 is high power measurements. So if we take a high power measurement, let's say 1 kilowatt or more, and put that on the face of a camera, we're going to burn the camera. Our CTO came up with a new technique for actually measuring very high powers. It's called beam watch, and that is the beam actually goes right through the center of this device and not touching anything. There's a camera in here looking at that and interpreting it right here in this image where we have one camera looking at the beam from two different angles. Now, how can we see that beam since our eye can't see that beam? Well, we affectionately call that, why is the sky blue? And that's the Rayleigh Scatterer effect. The sunlight, which has all the light of white light through all the spectrum of colors, is actually hitting oxygen particles, and the oxygen is re-radiating at all the wavelengths. However, our eye sees blue better than any other color. So we interpret the sky as being blue. That's exactly what we're doing with Beam Watch. We're imaging the Rayleigh scatter. So by imaging that Rayleigh scatter, we're able to actually measure the whole waste and caustic of the beam, looking for the spot size and looking at the spot shifting through the critical startup phases of any laser process. So with that, I'd like to thank you for your time. Please remember that our sales engineers are available for measuring your laser at your facility. See us on the web at ophiropt.com/photonics.